Hello, welcome to this lecture video. So this is the part 2 of the discussion on repeated measures ANOVA. So in part 1, we talk about the different assumptions of the repeated measures ANOVA. In this video, we will be considering one particular problem and generate what tables are needed for us to answer the problem given, of course, the sample problem. So here is our sample problem. So we want to compare the average rating for the 4 products. So this is how we can ask that question. Are there differences between the average rating for the 4 products? So let me just reiterate in the assumptions that these 4 products are being rated by each of our respondents. So it does not mean that one respondent, or rather one particular respondent, just simply rate product 1 and then another is product 2. So the product 1, 2, 3, 4 are all evaluated by each of our respondents. So our objective is to compare what or which among the 4 products is given the highest average rating. Okay, so to answer this, we of course need to open our data set. Okay, so this is the data set. So we have here an encoded product 1, product 2, product 3, product 4, our variables. And of course, it's also encoded here the average given by our respondents. So how are we going to answer the question? So first, of course, so we have to click Analyzed, General Linear Model. So in Analyze General Linear Model, this is where you can find the repeated measures. So we have to click that. And then the number of levels, we have 4 products. That's why we will be encoding 4 here. And then click Add. And then we will click Define. So we will be entering the product 1, product 2, product 3 until product 4 in place of within subject variables or factors. We have to click that. So right now, in our assumptions, we were able to talk about between subject factors and covariates, but we do not have this in this example. So our focus is simply to compare products 1, 2, 3, 4, regardless of whatever maybe is the other variables that might influence this rating. And let's click contrast. We have to make sure that the contrast is polynomial, though of course this is the default in the SPSS. So continue. So let's maybe consider also try to consider generating plot if it's possible. So for factor 1, add, continue, and post hoc. So we cannot click any of the options here. So let's close this part. Let's go to options. So in options, we can transfer this to display the means for. And in case that there will be significant difference, we can already generate its post hoc comparison just like in one-way ANOVA. So we will just change this to Bonferroni. So of course, we already mentioned when to use the Bonferroni test, LSD in our lecture on one-way ANOVA. So these are all post hoc comparison tests. So it's up to you if you still want to explore for descriptive statistics, estimate of effect size, and the others. So let's just check the estimate of effect size here. And the default for significant level is 0.05. And of course, the confidence interval, therefore, is 95%. So it's up to you if you will, again, replace this by 1, but since it will not cause any harm to our respondents anyway, so we can just simply set it to 5%, not a lower significance level. Continue, and but that is again your option. Click continue and last okay. So this is now the tables, the generated tables of SPSS. So we have test for multivariate tests. It includes PILAIS, Wilks, Hotellings, and Roy's. As you can see here, the result are all significant. So this is what we call the result also of MANOVA or the multivariate test. So this is the result of sphericity. We also mentioned about the sphericity in the assumptions. So we have to consider, of course, that in case we did not meet the assumption as mentioned in our first video, we will be considering its counterpart or alternative like greenhouse, Hohenfeld, or lower greenhouse or Hohenfeld. So we have here, of course, the result that will show that. So the fact that we click the effect size, so this is now the result also, the partial eta square. So in our next video, we will be talking about the interpretation of this. So as mentioned in our intro, this is simply how to generate the tables that is needed. So these are all the tables that we can use. So of course, going over the result. So we have here, as mentioned also, the generated plot. So we can see that the lowest is number 2, the highest is number 1, and almost similar for 3 and 4. And to find out if this product 2 is significantly lower, we will be, of course, interpreting this in the next video. Okay, bye-bye. Thanks for watching.